How do you get your vitamins? Perhaps you take vitamin supplements, perhaps you get it from the foods that you eat. This program is going to take a little bit of a look at in depth at three particular vitamins, vitamin A, C, and D. First off, generally what do we know about vitamins? Historically, their name came from the word vital amines. It was believed that they all contained amine groups. We now know that that's a little bit off base because we can find other functional groups and in fact some vitamins that don't have amines in them at all. First, they're also what we consider to be micronutrients, meaning we need very, very small amounts of them, considered to be less than 0.005% per kilogram of body weight. That would mean a 70 kilogram person would require about 3.5 milligrams per day of these materials. They act as enzymes, hormones, and a group of chemicals that are called antioxidants. Antioxidants have the ability to react with free radicals that are present in our body and remove them. And this has been shown that radicals, free radicals at least, have been linked to cancer-causing agents. Let's take a little bit more of a look at vitamin A. Vitamin A is not one single molecule, but rather a group of molecules that perform a similar function. In that case, they aid in our vision. Here's a look at a couple of them, retinol and carotene. You'll notice the similarity in that they both contain a cyclic hydrocarbon on the left end, as well as numerous arene groups that carry on a long chain proceeding to the right. Vitamin A, because of this long hydrocarbon faction, tends to be very hydrophobic, and as a result is soluble in fat materials like milks and lipids. The long alternating double bond has an interesting feature as well. This alternating pattern of double bonds, and we also see it in the benzene ring, are capable of absorbing parts of the visible spectrum, and as a result they tend to have very bright colors. So for instance, carotene, which is found in carrots, has that characteristic bright orange color. Vitamin C is perhaps one of the best known vitamins. It can be actually synthesized by many species on their own, but humans lack the ability to make it. Those species that can make vitamin C do so from the glucose molecule. You can recognize the sugars that are present in ascorbic acid or vitamin C. You have the numerous OH groups, you have the characteristic ring structure, and you also have a carbonyl group that's characteristic of sugars. It also plays a role in the production of collagen. Collagen is a fibrous protein that's linked with connective tissue. People that suffer from scurvy suffered from a lack of vitamin C and would often suffer bleeding from the gums. Vitamin C, as mentioned earlier, is water soluble. The presence of the numerous OH groups and the carbonyl group that's highly polar make it easily miscible in water. And it's also heat sensitive. Now this leads to somewhat of a problem when one is cooking or preparing foods that have vitamin C. First of all, cooking them in water for extended periods of time and high temperatures of water will tend to denature the ascorbic acid and leach it out of the foods, hence losing their valuable vitamin C content. Vitamin D is produced in small amounts in our body, usually in the skin, aided by the UV light from the sun. It comes from cholesterol, and you can see in the diagram on the right how cholesterol is turned into vitamin D, or cocalcifer. Now, it requires the presence of UV light for this to take place, which raises a bit of an issue. For those people who put on lots of sunscreen, you can essentially inhibit the production of vitamin D. So it is suggested that perhaps getting early morning sun or late evening sun would be useful for the production of vitamin D. If you're unable to get it from the sunlight, then perhaps you need to turn to other sources such as fish oils, eggs, and mushrooms. Vitamin D also helps with the uptake of calcium in our diet. Here you can see two adult femurs, the lower one being a healthy femur, and the upper one a femur that has suffered from a disease called rickets, in which case calcium is improperly deposited on the bone. You can also see that the molecule has mostly hydrocarbon in nature and hence also not polar and soluble only in fats. Malnutrition is a condition whereby we suffer from an imbalance or lack of supply of some of the diverse nutrients that we need in our diet. and it cuts across all socioeconomic forms. It can also be caused by a depletion of nutrients in the soil and in the water. The lack of education about the foods that you need in your diet can also lead to malnutrition. Processing of foods to enhance their transport and storage can reduce their nutritional value, as well as the use of chemical herbicides in the food production can react with some of the nutrients that are present in our food or even inhibit their production. Solution to some of these issues perhaps might include, first off, education with better food labeling that would clearly identify the vitamin content and how much of the daily requirement one gets of each food present. You can take vitamin supplements to help. Genetically modified foods can be made to produce more essential nutrients. And finally, we can fortify foods by adding to them necessary vitamins and micronutrients. So that's a brief tour of vitamins. If you have any questions, don't hesitate to ask, and thanks again for watching.